To finish the lesson on quadratic equations, we need to now go over some types of equations that are not really quadratic equations per se, but they are in quadratic form or of quadratic type, or some people even call them quadratic-like equations. And this means they're equations that, even though they're not quadratic, you can solve them with the methods that we learn for solving quadratic equations. So, how do you recognize an equation in quadratic form? Well, they're going to be equations that have three terms. Remember what the general term for a quadratic is. The general form of a quadratic is. The general form is ax squared plus bx plus c. And this is the way you have to make it look like before you're able to use a quadratic formula. So they're going to have an equation in quadratic form is going to have three terms, just like a regular quadratic equation. Three terms, and once you put them in order, the term in the middle has an exponent that is exactly one half the exponent of the leading term. So it's going to be half of it. So, for example, in a regular quadratic equation, the term in the middle, the exponent of the x is 1, which is half of 2. Okay, and then the third term doesn't really have a variable. It doesn't have an x. Okay, so there is three terms. The term in the middle the variable has an exponent that is half the bigger exponent, and then there's a third term that doesn't have any variable. That is a constant term. So that is a general form that it's going to have. It's going to have three terms. The first term is going to have a power other than 2, because if it were 2, then it would be a quadratic equation. But it could be any exponent, and the exponent could actually be a whole number. It could be negative. It could be a fraction, a decimal. The exponent could be anything. The important thing is that it's going to have three terms, and when you put them in order, the term in the middle has an exponent that is one half the exponent of the little term or the bigger exponent, and the third term is a constant. It doesn't have a variable. Okay, so that's it. Then that means that these equations can be then written in this form by introducing a variable u, meaning whatever your original equation was, if it was in quadratic form or a quadratic-like equation, then by introducing a new variable, okay, that we usually use u is a very popular variable for substitution, for changing variables. So by making an appropriate substitution, we can then rewrite our original equation into a bona fide quadratic equation. And the u is going to be, what is the u? Well, the u is going to be, once you put them in order and you look at the middle term, the u is going to be whatever that middle term is, ignoring the constant. Okay, so the u, I'm going to say that again. The u is going to be whatever is the middle term, once you put them in order, whatever is the middle term, ignoring the coefficient, ignoring the constant. Okay, so that's better understood with examples. So let's do a few examples. And what I just said is right here. Um, we can solve this type of equation as if they're quadratic by making a suitable substitution suggested by the middle term. Okay, so here's the first one. It says 2x minus 3 to the fourth minus 5, parentheses 2x minus 3 squared plus 4 equals 0. Okay, note that these two things are the same. Okay, first off. Then note that it has three terms, just like a quadratic equation. It has three terms. And this one is already in order. Note that the term in the middle has an exponent that is exactly half of the bigger one, of the leading term. 2 is half of 4. And then the last term is a constant. It doesn't have a variable. So it satisfies the properties of being in the same form as a quadratic equation. So what we're going to do is we're going to make a substitution. We're going to let u, so we're going to introduce a new variable. U is going to be the middle term, ignoring the coefficient, ignoring that minus 5. So u is going to be 2x minus 3 squared. It is the middle term, ignoring the coefficient. So we drop the negative 5, u is the rest. Okay, and the idea is that with this variable u, I can rewrite this equation, and it's going to be a bona fide quadratic equation. This term right here to the fourth is the same as u squared, because if you square that, if you square something that is already squared, you're going to get exponent 4. So that means this thing right here is actually u squared. This thing squared. Okay? In other words, 2x minus 3 squared squared is precisely the same as 2x minus 3 to the fourth, which is the very first thing I have right there. And this is u though. That's u, so that means u squared. Okay, then the next term is negative 5. Now I put the 5 back. Negative 5, and then this thing is u. So negative 5u plus 4 equals 0. And now you see that this is really a true quadratic equation. So by making a substitution, we change it into a real quadratic equation, into a true quadratic equation. Okay, now at this point, you solve this equation any way you want. Now you have like a ton of methods. You solve it any way you want. It doesn't matter how you solve it, just solve it. If it factors, that typically tends to be the easiest, followed by the quadratic formula. This one actually does factor because this would be u minus 4, u minus 1 equals 0. So that factors like that. And then remember what you do after you factor, you set each factor equal to 0. So that means u minus 4 equals 0, u minus 1 equals 0. And that means that u equals 4 and u equals 1. So u equals 4 or u equals 1. So we solved this quadratic equation, which is not the same as that one. Well, it is the same, but we're not trying to find u, we're trying to find x. So that means we're not really done because we have not found x. Okay, so now that we know what u is supposed to be, we can take it. Okay, that's u, and then but u in terms of x is this thing. So that means 2x minus 3 squared equals 4. So that's this equation, or 2x minus 3 squared equals 1. There's two possibilities for u. U could be 4 or u could be 1. But u is 2x minus 3 squared, so that means 2x minus 3 squared could be 4, or 2x minus 3 squared could be 1. And from here, we're going to solve both of these, and from here, we're going to find x. Okay, now the easiest way to proceed would be to take square root on both sides. So take square root on both sides, because it's already in the form something squared equals a number. So we can just take square root on both sides. And this would be plus or minus. Remember, when you take square root on both sides, you'd have to put plus or minus. Plus or minus the square root of 4, which is 2. So I took a square root on both sides, and we got 2x minus 3 equals plus or minus 2. Well, let me just write square root of 4 so that so you see all the little steps. Okay, so that means 2x minus 3 equals plus or minus 2. Okay, and now this means moving the 3 to the other side, This means that 2x equals 3 plus or minus 2. And that means dividing by 2, x equals 3 plus or minus 2, all that divided by 2. And we should simplify. There's two possibilities here. We should work them both out and see what we get. So the first possibility is x is a plus 1. So x 3 plus 2 over 2, which is 5 halves. So that's the first possibility. The second possibility is x equals 3 minus 2 over 2, which is 1 half. Okay, and so we have our two solutions from this. And now we solve this one and find what x is supposed to be if this was true. So let's see. Now this one takes squared on both sides. This is going to be take squared on both sides. That's going to be 2x minus 3 squared equals 1 equals plus or minus 1. We need to never forget about putting plus or minus on one side when we take square roots. The square root of 1 is 1. All right, and then, oh, I took the square roots. I don't need that anymore. Okay, now we're going to solve for x. We're going to move the 3 to the other side. So we're going to get 2x equals 3 plus or minus 1. And divide by 2, you're going to get x equals 3 plus or minus 1 over 2. And now we're going to work out each of the possibilities. First possibility is 3 plus 1 over 2, which is 4 over 2, which is 2. And then the other possibility is 3 minus 1 over 2, which is 2 over 2, which is 1. And those are all of our solutions. So now let's box them up. The four answers are 2, 1, 1 half, and 5 halves. Okay, so those are the four solutions of that equation. Okay, we're going to do another one. Two more, actually. If you already understood in the first one, then you're good. Maybe you should try this one to confirm that you really got it. If not, then just follow along and then maybe try the last one. So the last one has one more thing to it because the exponents are negative, but not a big deal. Okay, here's this one. 2x to the fourth minus 9x squared plus 2. So again, we recognize that this is a quadratic-like equation because it has three terms. Okay, it has three terms, and the term in the middle has an exponent that is half of the bigger exponent, which is 4. And the third term doesn't have variable, it's a constant. So this is an equation in quadratic type. So we're gonna let u be equal to the middle term, ignoring the coefficient. So we're gonna ignore the negative 9, so the u is going to be x squared. And that's the substitution that we should be making. With that substitution, this equation is going to become 2x squared, because squared is 4, minus 9x plus 2 equals 0. Okay, remember it should once you make the substitution, it should really look like a quadratic equation. Okay, it should really oh that should be a u, my bad. It should be u, not x. Okay, there. It should really look like a good like a true quadratic equation. Like this. 2u squared minus 9u plus 3 equals 0. Now you solve this any way you want, factoring, um, quadratic equation, any way you want. And for this one, I'm going to use the quadratic formula. Okay, so this is going to be u, applying the quadratic formula to this. U is, what is u? U is negative b, so that's going to be negative 9, so positive 9, plus or minus the square root of b squared. B squared is 81. Negative 9 squared is 81. Minus 4 times a times c over 2 times a. Okay? Now let's keep simplifying this a little bit more. This is 9 plus or minus the square root of uh, 4 times 2 is 8 times 2 is 16, and then let's figure out what is 81 minus 16. 81 minus 16 is 65. So 65, all that over 4. 2 times 2 is 4. All right, and that's it. We cannot really simplify this further. If you try to break up 65, 65 only breaks into 5 and 13, neither of which has a square root that is a whole number, so we cannot simplify that anymore. So we're done with that. So then we go back here and say, okay, this is u, but then let's put it back in terms of x. That means that x squared equals 9 plus or minus the square root of 65 over 4. Okay, and if we now we take square root to solve for x, if now we take square root on both sides, remember again not to forget to put plus or minus when you take square roots. We're going to get that x equals plus or minus the square root of 9 plus or minus the square root of 65 over 4. And it may look a little weird, but that's correct. That means there's going to be 4 possibilities involved by the different combinations of the plus or minus choices, and we're going to write out what all of the 4 choices are. But we can just simplify this a tiny little bit by saying this is plus or minus the square root of the square. Remember, when you have the square root of a fraction like that, the square root of a over b, this is, you can distribute the square root and say it is the square root of the top over the square root of the bottom. So then this is going to be the square root of the top over the square root of the bottom. The square root of 4 is 2. Okay, and that is the final answer, although we're going to now write out all the 4 possibilities. Okay, so that means there's four possibilities. So let's spell them out. X could be, so the first possibility is that you choose both of them to be pluses. So positive and positive. So first one could be 9 plus square root of 65, square root of all that over 2. Then the next one possibility could be when you choose the one outside plus and the one inside minus. So let's say 9 minus square root of 65 over 2. The next one could be when you have the outside negative and the inside positive. So 9 plus square root of 65, all that over 2. Okay, and then the last one is when both are negative. So square root of 9 minus square root of 65 over 2. And there is a list of all the 4 solutions. Okay, just one remark here. Remember that you cannot simplify this any further by saying you can, even though this is true for quotient, you can distribute the radical. You cannot distribute the radical over sums or minuses. So if you have something like this, you cannot say that this is 3 minus square root of 65. I mean, that is just wrong. You cannot separate this and take the square root of 9 and say it's 3 and somehow split it up. That does not really work. That is wrong. You cannot distribute radicals over sums or minuses or subtractions. All right? Okay, now let's do one more. This one has negative exponents. All right, I mean, they're all done the same way. This is a quadratic like equation because it has 3 terms. The term in the middle has an exponent that is exactly half of the leading term, and the last term is a constant term. So it satisfies the property of being an equation of quadratic type. And then we make the substitution. Let u be the middle term, this middle term, ignoring the coefficient. So the middle term is negative 6x to the minus 2. So we just let u be the middle term without the minus 6. So this is going to be x to the negative 2. And then just as before, this is going to become a true quadratic equation by writing that this is going to be then u squared minus 6u plus 8 equals 0. So you see that's a pattern. Square, exponent 1, and then the constant. And now you solve this any way you want. There's multiple methods. And I'm going to factor this one because it does factor. So u minus 4, u minus 2 equals 0. So set each of the factors equal to 0. So u minus 4 equals 0, or u minus 2 equals 0. So that means u equals 4, or u equals 2. So we found u. Now we have to find x. But u equals x to the negative 2. So this is x to the negative 2 equals 4. Or x to the negative 2 equals 2. Okay, now what does that mean? Negative exponent, really remember that negative exponent it just means you flip it. So this is 1 over x squared equals 4. And this one means 1 over x squared equals 2. Okay, now you can either cross multiply if you imagine the 4 as being a fraction like 4 over 1. So 1 over x squared equals 4 over 1, and you cross multiply. That means 4x squared equals 1. If you cross multiply, this times this equals that times that. Or another way to think about it at this point, besides cross multiplying, is to flip both sides like that. You flip both sides because whatever you do to one side, you have to do to the other one. So you can flip one side as long as you flip the other one. So flipping both sides is going to be x squared equals a quarter, which is really the same thing as that one. You get what would you get if you cross multiply, because the next step here would have been divide by 4. And if you divide by 4, you get x squared equals a quarter. So either way gives you the same thing. Now, doing the same thing for this one, flipping both sides, you're going to get x squared equals a half. We're almost done. Now take square root on both sides to get x. So x equals plus or minus square root of a quarter. And here, be plus or minus square root of a half. And remember, we can distribute this square root over the top and over the bottom. So this is square root of 1, which is 1. So I guess I don't really have to write that. Square root of 1 is just 1. And the bottom would be square root of 2. So square root of the top over square root of the bottom. Okay, and lastly, square root of a quarter. Again, you distribute the square root. So square root of the top over the square root of the bottom. Square root of the top is 1. Square root of the bottom is 2. And this one, you have a radical on bottom. We usually rationalize. So remember how do you rationalize? Get rid of the radical from the bottom. You multiply top and bottom by the square root of the bottom. So the bottom will be just become 2 because when you multiply square root by itself, it gets the square root disappears, and then multiply across, you would have square root of 2. All right, so that means another way of writing this is square root of 2 over 2, rationalizing. We rationalized. And those are the 4 possibilities. If you wanted to list them out separately, it would be, let me write the negative ones first. Negative a half, negative square root over 2, positive a half, positive square root of 2 over 2. Okay, those are the 4 solutions to the original equation.